Howdy. Earthquake watch, just a little bit to warm up. We are in the Baltic Sea once again. And there has been a quake some hours ago, 4 hours ago, magnitude 2. And since this is reported by Norsar, we don't have any depth or whatsoever. It's all blurred out. We can check out the island beside it, which has one interesting feature. I didn't go yet to Google Earth to check it out, what Majak Bolshoi Tyterstark means. But this, I think, is very interesting. I don't know what would cause a sandbank to grow like that perpendicularly. And there's even a little branching off going here. I don't know. Very interesting. An interesting feature. And there's another one, another island somewhere here, which has, in a way, a similar feature, which is just above water. Maybe. Yeah, there is maybe even a really small one. This being somewhat 300 meters long, so it's not that small. But I tried to make a video about one article which I came across again today, but I didn't have the time yet to talk about it because I think it's interesting. This doesn't really... Yes, no. The thing called cell phone didn't respond, so there was a little break, but now it seems to work. Waterworlds. Astronomers discover that 2 exoplanets are unlike any planets in our solar system. Earth, metals and rocks. Kepler 138d, metals and rocks, high pressure water, water vapor. So, I would say there is at least the water vapor missing on the left picture. You know, we have an atmosphere with clouds, which is water vapor. It's not drawn on the map on the left. According to this, there is no water vapor on Earth. This was already the first thing which I somehow thought that, what is going on? Did I miss anything? Cross-section of the Earth, left, and the exoplanet Kepler 138d, right. Like the Earth, this exoplanet has an interior composed of metals and rocks. Yeah, it's unproven, it's just a hypothesis. But anyway, they take it for granted. But Kepler 138d also has a thick layer of high-pressure water in various forms, supercritical and potentially liquid water deep inside the planet. And, oh man, and an extended water vapor envelope. Shades of blue above it. Have you ever watched Windy or some satellite pictures of Earth? There's shades of blue on Earth as well. Shades of blue and white, the clouds and the water, and the ice and the snow, which are also water in various forms. These water layers make up more than 50% of its volume, or a depth of about 2,000 kilometers. The Earth, in comparison, has a negligible fraction of liquid water with an average ocean depth of less than 4 kilometers. Yeah. But we have the water vapor layer, the clouds. This is something I really don't understand. Team of astronomers led by the University of Montreal, UDEM, find that 2 exoplanets may be mostly water. Astronomers have discovered evidence that two exoplanets orbiting a red dwarf star are water worlds, planets where water makes up a large fraction of the volume, located in a planetary system 218 light years away in the constellation Lyra. These worlds are unlike any planets found in our solar system. A detailed study of a planetary system known as Kepler-138 will be published today, December 15th. The team in the journal Nature Astronomy. The team was led by PhD student Caroline Biole of the Trottier Institute for Research on Exoplanets at the University of Montreal. Biole, who is part of Björn Benek's research team, observed exoplanets Kepler-138c and Kepler-138d with NASA's Hubble and the retired Spicer space telescopes. She found that the planets, which are approximately 1.5 times the size of the Earth, could be composed largely of water. These planets and the planetary companion closer to the star Kepler-138b has been discovered previously by NASA's Kepler Space Telescope. Water isn't directly detected. However, by comparing the sizes and masses of the planets to models, they could conclude that a significant fraction of their volume, up to half of it, should be made of materials that are lighter than rock, but heavier than hydrogen or helium. You probably, hopefully, have been thinking about the hydrogen as well as I did, since I have seen the calcium is crazy video. If you drop calcium into water, it releases hydrogen gas. And as it surfaces in this little experiment, the bubbles, they form water vapor because they start to bind with oxygen. If the chemist who does the experiment starts to enlight or gives a flame to the bubbles, they explode because it's hydrogen. But there is no water vapor anymore. So my theory is still, is there any possibility that through certain mechanisms within Earth, there might be rising hydrogen gas out of mountains, and they are creating the clouds? I don't know where you people live, but I have been in the Alps many times. Where I grew up, there has been those hills, like a little bit bigger ones and smaller ones. But it's a hilly landscape with rivers and hot springs and all kinds of stuff. Many dragons, many castles, many churches. But anyway, I have been watching these clouds all my life when I lived there. And I somehow found it really intriguing that there are somehow like similar places where there's just the clouds hanging around at the hillside. Like, why? Why it's always the same place? What's going on? Sometimes it has been after rain. Sometimes there wasn't rain. There was just the clouds and the mountain or hill. So it could be, if there is an electrical discharge event called rain, the water flows down the rocks, and as it reaches a certain depth and it comes across some calcium-rich rocks, it could be that it starts to react slowly, like over time, because it seeps through the rock downwards, and as it reaches a certain layer of rock, maybe they start to emit hydrogen because they get wet. Calcium gets in touch with water, and the hydrogen maybe starts to rise in a way up in the hill. Maybe not through gravitational forces, but electromagnetic forces which can easily overpower whatever gravity there is, because gravity is also just a byproduct, so to say, of the electromagnetic force. But anyway, I drifted off. Water wasn't directly detected. Let's read just this once again. Water wasn't detected directly. However, by comparing the sizes and masses of the planets to models, they conclude that a significant fraction of their volume, up to half of it, should be made of materials that are lighter than rock, but heavier than hydrogen or helium, which constitute the bulk of gas giant planets like Jupiter. Water is the most common candidate material that fits these specifications. Check it out. What a rabbit. We previously thought. So this indicates that they probably are about to learn something new. We previously thought that planets that were a bit larger than Earth were big balls of metal and rock, like scaled up versions of Earth. And that's why we call them super Earths, explained Benecke. So now let me show you just quickly one picture, which is actually very bad quality for whatever reason. Maybe it's a screenshot of a screenshot of a screenshot. Maybe one day I find the original, which is sharp. But let's just go with this. This is some thought about how Earth could be in nature, because I see it as a living being. Earth is alive. There's many things going on all the time. Lightning, earthquakes, waves, wind, whatsoever. All kinds of things are indications of it being alive. So, there is in the middle lab plasma drawn very sketchy into that, which is basically just the try to show that there might be a plasmoid in the center of Earth, which creates the heat and all these other things, which keeps us alive, the spark of Earth. And where you have parts like this, where they touch this outer sphere, whatever plasma ball that is, I don't know. These might be the places where we have volcanoes and these kind of things, because the crust might be very thin. It might be somehow, in a way, more directly attached to the actual core. On the left side here, it's not really visible. We have a geoid and also Walt Thornhill's repellent core. And if you watch at the numbers, I hate numbers. Deepest quake ever recorded, as far as I know, 987 kilometers. And to the center of Earth, there's about 5,877.5 kilometers still left from that deepest quake ever recorded. So there would be space for quite many things within that range. But anyway, back to this article, because I still wanted to show you another article about this similar theme. However, we have now shown that these two planets, Kepler 138c and D, are quite different in nature. A big fraction of their entire volume is likely composed of water. It is the first time we observe planets that can confidently identified as water worlds, a type of planet that was theorized by astronomers to exist for a long time. We previously thought that planets that were a bit larger than Earth were big balls of metal and rock. Yeah, we had this already. But anyway, maybe it's not bad to go over it again. Like scaled up versions of Earth that's why we call them Super Earth. However, we have now shown that these two planets, Kepler 138d, what? Haha, it's twice, check it out. It's the same article twice on top of each other. So, don't blame me for getting a little bit disturbed by that. So, with figuring that out, I just wanted to show you another article about water. And since I have been talking about mountain water and all these kind of things for many, many times already, we have to go to the Economic Times. No. I just searched for an article about this. There might be many others. The numbers might fluctuate. In some places they say 100 times, sometimes in other places almost 1,000 times. But water exists deeper in Earth than thought. Study. Synopsis. Based on high-pressure experimental studies, scientists knew minerals that transported water, such as brucite, had limited stability and that these minerals decomposed in the deep Earth. That's almost 6 years old. It's older than 6 years, actually. Washington. Now settle down. Water exists far deeper in the Earth, about 400 to 600 kilometers into the mantle, than previously believed. Researchers, including one of Indian origin, have found a mineral far below the surface of the Earth may hold the key to how much water is stored in our planet. Researchers said, Maniak Mokhirie, I really hope I didn't butcher that, assistant professor at Florida State University in the US, and Andreas Herman from the University of Edinburgh in the UK, estimate that in the deep Earth, roughly 400 to 600 kilometers into the mantle, water is stored and transported through a high-pressure polymorph of the mineral brucite. Previously, scientists thought brucite was not thermodynamically stable that deep in Earth. This opens a Pandora's box for us. We did not think water could be stored by hydrous minerals such as brucite. But now that we know it is there, we need to figure out how much water could be effectively stored inside it. Mokri said, "Shh, listen. Based on high-pressure experimental studies, scientists knew minerals that transport..." Man, it's important. Based on high-pressure experimental studies, scientists knew minerals that transported water, such as brucite, had limited stability and that these minerals decompose in deep Earth. That's repeated again. As they decomposed, they released the water, which is recycled back to the surface via volcanic activity. Okay. However, this discovery of a new high-pressure phase of brucite indicates that water could be efficiently transported to far deeper realms without decomposition. We had to do quantum mechanical calculations of thousands of potential structures until we found the one we now reported, Herman said. It really is remarkable that such a well-studied mineral as brucite has something so surprising to offer. Haha, yeah, that's really interesting, you know. I haven't read this through yet, so... Man, for those who have heard about mountain water, you probably understand how I get excited. Maybe that's the reason why the chickens freak out. They feel the vibrating, the change in my vibration. You know, it wasn't easy to get into a state of being able to make a video. And now as I go further into that, it seems to work. I take that as a yes. Anyway, water plays a critical role in sustaining geological activity below the Earth's surface. Scientists have been working for years to quantify the ocean's worth of water that lay hidden in the crust and mantle. For the activity of the planet, deep Earth water is actually important to water on the surface. And I have been trying to explain this. Let's draw Earth. Let's take water. There is this layer of water in Earth's crust somewhere. There is electricity running through Earth. In whatever ways it does it, through Birkeland currents and stuff like that. If the current is increasing, let's take red color in order to increase the current. This water layer here, probably, I don't know, it will change in size. It will either shrink or grow according to the charge of the whole body. I can't tell you if it will shrink or expand, if it's getting like more charged or less charged, I don't know. If someone knows, tell me. It would be very interesting. I just think at the moment, since we have had all these drought occurrences in Europe and wherever we have it, the water has been retreating. Probably it's coming back once. And there could be a possibility that it is much more than it has been previously. But that's just another thought. My goal is to understand how much water is stored in the deep Earth. If the planet becomes dry on the inside, the planet dies because geodynamic activity within the planet ceases. No. The research was published in the journal PNAS. Yes. No. There will be always water. It's hydrogen and oxygen. So they will find each other, you know. Because there are plenty of them out there. But just for the science or whatever, I think this has very much to do with mountain water, what the things I've been talking about. And also with the white rivers, which you can find all over the planet. Mount St. Helens in the USA, which has the world's fastest growing glacier within its caldera, and it has several wide rivers. It is a cryptodome, it is a volcano. Nalchik, Russia, Montmort in France, Udine, Italy, Parma, Italy, Walgau, Germany. Wide rivers. The water within the Earth, you know. So just for recapitulation, going back to this article, Waterworlds and this map. The comparison between Earth and Kepler. Earth is just made out of metals and rocks, no water whatsoever. Why is it missing? Why? This doesn't make any sense. You know? Cross-section of the Earth left and the exoplanet Kepler right. According to whoever made that, there is no water on Earth or whatsoever. Something is missing in that picture. But anyway, I leave it here. Thanks. Bye.